we have just introduced the support vector machine in simple way. What is a support vector machine and where it is lying? So to understand the support vector machine, what I am doing today, I will take an example, and I will explain such example with the help of the support vector machines along with all its term. And what are those terms? Hyperplane, descent margin, and support vectors and other terms we will see step by step. So rather than seeing the all the things by the graphical way, I will explain all the things by the one graph and which will describe everything in detail manner as well. So now we have big question right now. What is a support vector machine and where it is lying? So for doing the revision part, what I will do, I will take one more blank slide over here and explain everything in detailed way how we can understand the support vector machine easiness. So what we have to see, the point we have to see in our mind. Let me explain once again. The machine learning has three its flavor. First one is the supervised learning. Okay, this is the statement I'm writing here to only those students who are still sleeping, but those who know all the things, it's good. And if we talk about the other part, that is the unsupervised learning we have. In this slide, you will find everything so far what we have covered from the machine learning point. Now, next we have a reinforcement learning. And whenever you feel any kind of the problem, you need to ask anything, you can disturb me so we can discuss once again. So reinforcement learning. Now, first we have a big question: what is a learning? So what is a learning? So learning means to understand the our concept in simple way with help of the various source of the mechanism. So the learning will be kind of the behavior. So our behavior will try to implement, our behavior will try to understand the thing in detailed manner as well. Okay, so this is the so learning can be easy, but by the resources. And what are the sources? We have it to different ways. So in the machine learning, we have a different way. What are those? Supervised and supervised reinforcement. Supervised learning, we have seen or we have divided our two parameter. One is a regression and another one is a other one is tell me yes. What was the other one? Classi- Classification. This one is good. Why I'm writing all the things over here to just explain the idea so far what we have covered. In the regression, we have seen the first point that is simple linear regression as per our syllabus. Okay, simple linear regression along with some numerical aspect. In the simple linear regression and except in simple linear regression, we have a different kind of linear, different kind of regression, polynomial, multiple. But as per the syllabus, we have not touched. But if time permits, definitely we will see, or I will explain by the practical part as per the my words. Okay. Now, next, we have seen the classification. In the classification, what we have seen the logistic regression, logistic regression. And the regression we have seen in detailed way by the subnumerical. In the classification, we have also covered the descent tree classifier. Descent tree classifier. Descent tree classifier. And this concept we have seen by the ID3 algorithm. Okay, so ID3 algorithm. Now, other than these two algorithms, now it's time to see the support vector machine classifier. So I'm writing here the support vector machine classifier. Okay. Now, why I'm writing the support vector machine classifier? This is the big question. Sir, why we are not using the this support vector machine the regression? Yes, of course, it is possible. So, doing this one, what I have the simple idea. If we have a continuous nature of the data, if we have a continuous nature of data, then we have a support vector machine regressor, and that is also possible. When we have the continuous nature of data, then a descent tree classifier, I'm writing shortened way dt regressor is also possible. Okay, regressor, I'm just writing correctly. If we have a categorical data, So we have the logistic regression. Okay, that part we have already seen in the regression terms. So I'm writing here for your interview purpose. If someone asks you the question, if you have a discriminator, it is possible or not. So you must be damn sure about this point. Yes, search is also possible. So after the logistic regression writing, I'm just we can say the we have a SVM. So SVM is also possible, and dysentery is also possible. So I'm writing the SVM classifier, and sometimes you can find this is also written into the many books. SBC is a support vector classifier, and this is also known as DTC, that is a dysentery classifier. These are the points. So when we have to continue nature data, so what kind of the other approach we have? Yes, of course, simple linear regression. So I can write linear regression like this. So these are the two type of the information we have seen in our previous class. Now here we have a big question: what is mean by the support vector machine? So the question we must have in detail way. So question must be in detail way. What I am speaking over here, because there are many form of the question asked by the anyone. So you must be keep in mind all the points. So here I am writing the answer of the support vector machine. So I have the answer in simple way. Support vector machine or SVM is a classification. Why I'm writing the classification? Why I'm not writing the regression? As I told you many times, many of the people will love to work with the support vector machine as a classifier rather than the regression. But when we have the SVM algorithm along with the continuous nature of data, then we have to speak about the SVM regressor. So this is the point you have to keep in mind. So SVM is a classification problem, as I'm just writing in simple way, because we have to keep in mind this is not only the classification problem, but most of the people will use SVM as a classification problem. So SVM is a classification based machine learning algorithm. Machine learning algorithm. This is this is used to classify data. It is used to classify the data based on based on support vectors based on support vectors. Now we have a question right now. So what are the support vectors? I will tell you with the help of the example. So what I will do, I will explain everything by the graphical way. So rather than the picture, I have the pictures. Rather than the pictures, I will explain all the things by the graphical way. So I will take an example. I will explain all the things by the graphical way. What is the this one? What is this parameter? So I will write everything, and then I will speak each and every individual term to understand what is the sense of that part to use in this part. Support vectors. Next, we have the support vectors are more important. So while discussing the support vectors, we have some terms. Those are known as a hyperplane. Okay. Next, we have a descent margin. Okay. So these are the some terms which are required to implement a support vector machine in simple. Okay. So this is a simple definition. So what I have written over here in this slide is clear to all right now. So we can understand the support vector machine with help of the example, and that is real application. Yes, tell me. Anyone who have any doubt? This is the part we have seen the previous class. So this is the point. Yes, tell me. Yes, tell me. Is it clear or anyone who you need to ask?
No, it's clear.
Okay, that's good. Now, this image you are able to see, it is written over the example. So we are given the set of the people of the different features. So what are those features, height and weight we have? Okay, so these are the what? These are the two parameters given into the form of the features. One is a height and weight. So the information we have in two forms. One is a female and the one is a male. So based on the gender feature, we are dividing the data into two parts. One is the height and weight. So we have a features. We have a features. What are the features? Not one feature. We have multiple features. So we can say we have features, height and weight. So based on the gender, we are distinguishing. We are classifying the data. So here we have a classified data. Okay. From this classified data, we will try to depict everything. Okay. Now, this information is clear. The problem is clear. So what we have to understand, if we try to insert a new data, we don't know it could be the male or female. So we need to predict. So we need to predict. If I'm predicting something by the support vector machine and after classifying the data, so if I'm giving the new input, are we getting are we getting the prediction in correct way or not? So how we can judge or how we can predict based on the support vector classifier or support vector machine regression. So this would be our problem. So before dividing everything, we have a some parameter. So step by step we'll see. So is it clear to all right now? So what are the data we have? Then I will draw everything in the graph.
Yes, sir.
Okay. Now let me just use a graph and please keep in mind all the points properly. I will explain all the things here in the ones. Go back and see what are the data we have. So we have a height and a weight. So can you tell me right now what would be the height and what would be the male? What would be the X and what would be the Y? Tell me what would be independent, what would be dependent?
The height and weight are dependent on each other.
Oh, dependent on each. Yes, good. So what I'm doing right now, I'm assuming this one is a weight and this one is a height. Our entire class will be on this slide, which will try to solve our problem based on the support vector machine. So we will try to solve this problem. The problem we have given data. So we have to classify our data into two parts. And if we try to insert new information, then we have to judge or we have to predict is this male gender or is it female gender. So let me draw everything by the male and female. So what I'm doing, I'm just choosing the different color dots which depicts the this is the female kind of the information or this is the male kind of the information we have. Now should we continue or just so far you have so you can ask any question if you have any doubt. Just tell me anyone who have any doubt or should we should we continue to solve the problem and
Sir, continues.
yeah, okay, thank you.
Continue.
Good, good. So from the weight parameter, if you're writing, so I'm assuming the x-axis on the data or on the axis, we are writing the weight. So weight is just following by the x-axis. So what are the information we have? See, minimum we have 90, 80, 80, 85, 72, 65. So we can start from the 65. Okay. So yes. So what I'm doing, I'm just starting from the 60, 65, 70, 75, 80, 85, 90, 95, and last I'm taking the 100, which is not available, but we can easily understand. And what is the minimum value of the height we have? 170. So starting from the 175. Okay. So we can use 172, 171, 172. And what was the maximum? Maximum we have 187. So we can mark till 190. If I give you this kind of question in examination, then you will easily understand how to solve such problem. So everything, the every step should be clear in your mind as well. Do not miss any steps today. So if you're missing anything, you will lose your information. So please keep in mind all the points in your mind as well. I hope I'm writing everything here. It is visible to all and it is clear to all what I'm writing. Yes, tell me.
Yes.
Yes, sir. Yes, sir.
See, rather than jumping on the different images, I'm explained all the concept in one graph, so everything will be clear on a one slide. You people are not need to worry about the other part as well. So this is the 190 and last I'm just taking the 190. Now let us make change the color of this one. So red color I'm taking the female group. So weight will we have the weight 65, then height is 170. When we have the weight 65, then height is 64. So this will be the 1 point. Okay. So I'm marking as a dot, which is a red. Next we have a 88 and then 174. 88. So we can say this could be around something. Uh, Height is 88. Yeah, so this could be 170. Okay, so 88 we have. So we have 88. This one, and here we have 88 and 174. So 88 we have. So we can say this would be here. Okay, so please assume it. Let me write into the this way in this way. Now next one is 75, 175, 75, 175. It will be close to this one. This one data we have, and so we can mark like this one. And this one I'm marking. Okay. Next we have 65 and 80. So 180 and 85. 65 and first 65, 180. 65. So we can say 180. Something like this one. And next we have 80 to 185, 80 and then 185, something like this. And now next we have what we have 179. So now let me change the color. So for the male group, so 90 and 179, 90 and 179. I'm just taking the 90 and 170, 90 and 179, 90 and then 179. So it would be around like this. Next 80 and 180. So 80 and 180. Next is 80 and 23. So 80 here will be 83 could be like this one. And if we have a 85 and then 187 and then 187. So 85 we have, then 187. So it could be around like this one. Next we have 72 and 182. 72 and 182, something like this one. So all the black points which are representing were the millimeter. So here what you are observing, this belong to the male. Okay, so black dots, and the red dot are representing by the female. So from this parameter, we are not easily to identify. Why? Because here what we are observing, some data points are mixing. So classification cannot be done easily. So what we have to do, we have the two options. Either we can leave the problem, or we can continue by the changing or swapping the its parameter. So we can say the weight or height we can replace to justify the word. So what I'm doing in the next slide, I'm just changing uh, all the information just like this way. Just let me. Okay. So from this parameter, what is the problem we are having? So first, let me give you idea by this level.
Yes, the sorting between the female and male, the one female is on the top.
That is the reason, because from this point we were unable to classify. So due to this reason, we will swap the our height and weight, and this would be the good exercise. So it is not easy to determine the independent dependent variable the SVM. So that is the reason. So if just look at this point, and this is the point. And if you are just making the group like this one, just you can just look at the my. So here what we have a problem. So this is a problem actually. How we can solve this problem? We can solve this problem by the kernel function. So this is the problem. And when we have this kind of the problem on the our 2D graph, then we have to transform our information 2D to 3D by using the kernel function. So problem can be, I can write over here, the problem can be sorted out. Problem can be sorted out by kernel function. That part we will see later on, but here we need to understand the kernel function. Okay, and what is the kernel function? The kernel function is used to transform your data point into the one dimension into the another dimension to sort out the problem, and which will use the data in simple manner by which we can easily classify the information. So that is the problem. So here we will not leave the problem. So what we have, the other option we have, we can transform, we can swap the height and weight. So maybe we can easily understand, and from that parameter we can solve the problem. So this is not a big problem, this is simple problem. But here how we can solve this problem, so I have mentioned over there. So now what I'm doing, I'm just moving to the my next slide, in which you can easily understand the everything. So I'm just doing uh, this one, and I'm just taking the rough data only fastly so we can easily understand. I'm taking this here. So here, what I will do, I'm just making another graph, and I will explain everything on this graph. So what I'm doing, I'm just marking this would be the our weight and this would be the our height. So after replacing this one, I hope we can sort out the problem. So height we are just assuming over here, and as we know what is the minimum value of the height and what is the maximum value of the height, you can observe over here 170 to 190, you can say our height. So here I'm just writing all the points. 170, 170, 2. Okay, I'm just taking the 2 gap. So 174, 176, 178, 180, 182, 184, 186, 188, and last I'm taking the 190. Same thing I can use with the height. So height, when we have done now weight. So our initial weight was the 60 and 100 is the maximum. So we can say this would be the 60. This would be the 62. 62 will be very not easy. 65 we must take, and 70, 75, then 80, and then 85, then 90. I hope by this problem we can sort out the problem, and this. So in the SVM, it is very easy problem. No, it's not easy to find the independent and dependent variable. If it is given, then we can easily sort out. But if it is not mentioned, then it was not easy to identify. So let me explain all the things step by step. So now I'm just choosing the blue color data points, and these blue color data points will be the male. Okay. So first I'm taking the male part. So male. So we have a 90 to 170. So we have a 90 weight and height is the 170. So what is the height? 179, and the weight is the 90. So when we have the height 179, so weight is 90. So this one I can take the I can take over here. Just if you are agreeing with me, so say yes or no. Can we plot this first data point?
Yes, sir.
Good. So now next we have a 180 and 180. So 180 and 80. So this would be the another data point. Just please keep in mind that all the blue data points are representing the male category. Okay. So I'm just marking a different way for easiness. And from this point, I will tell you what are the support vector, what are the hyperplane, and what are the role of each every point. Next, I'm just coming back to 183 and 80. So 183 and 80. So it could be like here. This could be like over here. And next we have 187, 85. 187 and 85. So 85 may come here around like this one. This one. Okay, I'm not putting on the exact root, but I'm just assuming. And next one is 182 and 72, 182 and 72. So that would be like around on this position something. Okay, now I'm changing the color to use the female data, so we can easily understand. We have a 174 and 65. So 174 and 65, so that would be over here. Tell me yes if I'm going wrong, so you can intervene me. Is it right? Next one is a 174 once again and 88. So 174 and 88. So that would be around something like this one. Next one is a 175 and 75, 175 and 75. So this would be around like this one. Next one we have 180 and 865, 180 and 65. So this could be around on this position. And the last data point we can plot over here in our graph. So 185 and 80. So 185 and 80. So this 185 and yes, I did 80 and 185 and 80. 185 and 80. So we have got the right position. Again, we are. Let me check once again. This one is in the right position. I think. Yeah. So 185. So what I'm doing is I'm doing some amendment. See, if you're again going through the 185 and 80, so again we will stuck in a situation. So what we're doing for sort out our problem, I'm just doing some little changes over here. So what the changes I'm doing, I'm just changing here. Rather than the 185, we can say if you're moving 185, so definitely it will be part of the male category. So what I'm doing, I'm just changing its initial value to make a perfect classification. Instead of the 185 or yeah, so we can make we can take 170. So 170 height will be better. Okay, I'm just changing. Okay, to sort out the my problem. We can change it 185 to 170. So it 18. So this will be the perfect solution we can put. Is it okay right now? We can 170, 175. So our problem can be easily sort out, or we can make the classification simple. Now tell me yes or no.
Yes, sir.
Okay, so we can at least sort out some problem. So I'm just trying to replace my value 185 to this one. So now we can easily see over here now our data divided by the two groups. So splitting we can easily do. So splitting of data we can do in easily manner. So this is the reason I'm just changing something over. Same thing we can also do with the previous one, but we are finding we are unable to classify. But again we are getting the same thing. So what I'm doing, I'm changing something to the my data set because we need to understand the entire concept by the SVM. So manually we have to do something. In terms of the practically, we can use a kernel function. So here we are not able to use a kernel function in easily, but the mathematically. So, but before that we have to change everything. But we are doing anything in the support vector machine. We are expecting to apply the kernel function. This is the reason what I'm doing for learning purpose. I'm changing this value height to 185 to 170, and weight I'm not changing anything. So I'm just keeping the weight value as it is. So my data will be plot on the right position to classify the my data. Now this plotting is clear right now. Why I did? because I need to understand the SVM properly. Now, clear right now?
Yes.
So why I did, because my data will seen to on this picture like this one. So group of the male and group of the female we can easily see. Now you can see this point right now. And do not think about the height and weight. So because this was the image containing the wrong information, so this is our problem. So please keep in mind the instead of the this height, this would be not height. This would be the weight. This would be the weight because minimum weight was the 60. Okay, so this is the reason, and this one would be the our height. So why I did, because I need to make the group into the separate one, and in between there's a string of the gap we have, so we can easily understand. Okay, so let us continue our sort out our problem on this graph. This, okay, this one is a new data, and this data I just plot coming into the random position. I can take the person who belong to the weight 95 and just 175 is height. Okay, so this one is a new data. Yes. Now, so our objective today in this PPT, to understand our objective to classify and predict the new data, new data. So it would be male or female. So can you tell me right now what would be the category of this new data? Hmm. Tell me. Can you see on this graph and tell me how we can identify to try to classify the data? This would be the male or female. From this parameter, can you justify this one? Just tell me. Can you justify the my words? Is it easy to identify from this parameter? From this graph, can you justify?
No. Or
So that is the reason what we have a support vector machine, and from support vector machine what we have done, we have added new data point and we need to figure out it is a male category, female category. So what we have to do, that is my point. So from this point we will try to explore our idea about the support vector machine. So we need to split our data first. That is our responsibility. What is our responsibility? We need to split our data into two parts. So what are the two parameters we have? So we have, see what I'm doing. I'm just dividing my data two points. So first line I'm taking by this way. See, from this data point, please keep in mind from this data point, I'm assuming I can classify my data point like this way. This is a line one. Can I say this is a line one? By which I'm splitting the my data? Just tell me. Can anyone tell me? Can I say this is a line one by which I'm dividing my data? Which is a green line? Just tell me.
Yes,
Just
sir.
tell me.
You can. Yes, sir. You can divide. But sir, what will happen if the new data is on the line?
That is a good question asking me. I will always speak. The point I'm asking, can we use this as a line one by which we are dividing data? So this is the point. So for the few couple of the second, just forget the data which are plotting on the new data, which are not on the line. First, we are dividing our data. Just keep in mind this one. So can we divide our data this one just like this one? Okay, for a more curiosity, what I will do just uh, this data point we have. Okay, just I can give you an answer in simple way. I'm using the different same kind of a line, so I can make this line. Just keep in mind. See, what I'm explaining the working with the support vector machine by the graph. This is the line one. So if I'm choosing the line one, we can say our new input data will be the male category. Tell me yes or no, am I right or wrong?
Yes, sir. In this case, you are right, sir. But sir, in some case, it could be exception.
No, that could be not exception. That could be the possibilities. So let me change the different color, and then I will tell that I'm just choosing the another line. So what I will tell you, what are these things? Yeah, definitely you are on the right point. So by the graphically, you can easily understand. Next, I'm just plotting the another line from. I need to choose this line from this point. So now, from this line, we can say this is a line 2. If this is a line 2, so by the line 2, I can say my new input data will be the female category. Can I say?
Yes, sir.
So the question we have over here, which line I must choose? Because on the graph, I'm dividing my data by the lines. So I can draw the multiple lines. So from the lines, I can say if I'm choosing the line one, then my data will be the male category. If I'm choosing the line two, so my data will be the female category. So again, I'm confusing. Say yes or no.
Line
Yes,
one,
sir.
sir.
So why I choose the line one and why I choose the line two? That is the biggest.
Sir, because the first data you have put the new data, it's male.
No, no, no. It doesn't mean. It doesn't mean if I'm plotting my data points, my new input data information.
So,
I'm
sir,
plotting.
it is their possibility that the line is choosing according to their slope.
Okay, that is a point I'm getting from the students. So, what is the other student thinking? If I'm choosing the line one and line two, so what would be the? That was my point. So here we have a big question: which line I must choose? Again, I will confuse. So that is the reason I'm asking to you. We can have the multiple lines. So we can split our data by choosing the any one of the line. But here the big question we have. If I have the choosing the line one, so my data will be male. And if I'm choosing the line two, my data will be the female. So this is a confusing question. What which line I must choose? That can split my data in the best way. So our objective to predict the gender of the new input data, and we should split data in the best possible way. So from the line I'm choosing, but the question I'm still asking once again, which line I must choose? Then I would say the best line is split the data. I'm 100% agree. But again, you are confusing. Which line I must choose? Line one or line two? So now you were stuck in a situation. So to understand this problem, we have some terms, and those terms we will discuss with the graphical way as well, of course. But in this graph, what my was objective to explain everything, we are trying to understand support vector machine. So from this parameter, we have put some good images and why which I can explain. So shall we move to the images or shall we explain everything by this graph only? You have two options. Just tell me right. You have options. Now tell me, should I explain by the image or should I explain by everything by this graph only?
Sir, there can be infinite number of lines, right?
Of course, there can be infinite number of the line. Not infinite, not
But we have
infinite.
to.
We can say n number of the lines depend on the
Yes, sir.
possible line we can say draw.
Yes, yes.
So that's the problem. So from this point, tell me what is the problem? This is the biggest problem. Okay, let me explain over here. So from this parameter, I've been sharing the some images. From the images, you can easily understand because I have the multiple images by the changing the pictorial information. So this point we have seen. Just are you able to see this? Tell me yes or no. Are
Mhm.
you? Yeah, do not think about the height and weight parameter. Just think the only the graph what is we have. So we have a two groups. One is the male group, and another group, and we have inputted new data. Just you can see, I have just inputted new data. Is it visible to all right now? New data plotted at the random position. Is it visible?
Yes, sir.
Okay. So as the next step, what I did use the two lines, line one and line two. Same we have done. Tell me yes or no. So if I'm choosing the line one, so my data will be the male. If I'm choosing line two, so my data will be the female. This was the confusion. Tell me yes or no.
Yes, sir.
From this point, to sort out this problem, we have some parameter. And so what is the big question? I have already written over here. I will share the PPT, no problem. So which line is the best to split the data? This is the confusion. So for to understand, that is the point. To understand and to choose a proper line that can split the my data properly to predict the new input data that could be male or female, we have to use some terms, and those terms belong to the support vector machine. And from this point, actual support vector machine working is going to start. So here we have point. So how do you say the best split right? So line one or line two? Okay. So let us understand this point. If I'm choosing the line one, are you able to see the screen? Just let me right now. Are you able to do the screen? Just and able to see the screen as well?
Yes, sir.
Okay, good. So now from this selected slide, we can easily say baseline selection will be based on the maximum space. And what is the maximum space? And how we can identify? So from the graph, you can easily say the line has the maximum space that separate the two classes. Here classes means what are the classes? One class belongs to the male and the class belongs to the female. So you can say the partially dotted line are drawn. You can just see. Here this is a dotted line. You can just dotted line. So if I'm choosing this one. Now let me come to the my graph. From this graph, I can explain in easily way. So now let me move back to the my graph. Yeah. From this graph, let me take the different color so you can easily understand. I'm taking the this color. See, suppose I'm choosing line one. So from the line one, and parallelly what I do, I need to find the maximum space. Okay, so what I'll do parallelly or parallelly, I will draw something here. So just my drawing will not be good, but I'm just explaining. No, if I'm choosing line one, so I need to uh, draw the everything properly. This one, and this one is. So do not think about the this point. Okay, so let me write properly. Parallelly, I'm just going. Do not think this data is available. Just think only the this line one. So parallelly, what I will do, I will just draw dotted line, or I can take a line. Okay, okay, and from this point, do not think about the line two. Okay, just think. Okay, I think I'm assuming. Uh, First, let me explain the line one. First, I'm taking the line one. Okay, to avoid the confusion, first I'm taking the line. Okay, this is the line one. And now I'm just taking the different color to show its parallel. Parallelly, data may be on the line, no issue. This is the point. And we have to use this another point. So what we can say, what is the maximum space? Maximum space means parallelly we are just draw the lines which are close to the all the classes data points. So there will be no variety, all the data points will be, but some data points may close to the line. So you can observe over here, what you can observe over here, you can easily observe over here, this line is close to this point, just, and this line is close to this one. Just look at the different color data points, or just look at this one, and I can use my pointer so you can easily understand. uh, this is pointer. Just look at the my pointer where just I'm just marking or representing the this point. The blue data point which are close to this sky blue color line, and the red data point which are close to the sky blue color line. It is visible right now, both are things.
Yes, sir.
Yes, sir.
Good, good, super. So what is the meaning of the maximum distance? So this is telling to us the gap between, or the distance between these two parallel lines. So this is known as the maximum distance. Maximum distance. And you can also do the same thing with the other one. And what is the other one? If you remember the line two, so what was the line one? Line one I have taken from this one, suppose like this one. So if this one was our line two, same thing we will do with the maximum distance. We will also calculate or determine by the line one and line two as well. So what I'm giving its maximum distance. As a name suggests, maximum distance. So if we are getting the maximum distance by the line one or line two, so we will see which line generating the maximum distance, and from that parameter, we will select the line, and that is known as the selecting the best line to determine the maximum distance. And this or the selected line will be known as the hyperplane. Mathematically, I'm speaking. Now it is clear right now. Let's just move to our image by which you can more easily understand. Then you have a doubt, so you can easily tell me. So now go back to our image. This one. So for the line one, I'm determining the maximum space or maximum distance. So this would be the one parameter, and same thing we will do the line two. So line two, I'm also getting the maximum distance, but after comparing the distance, maximum distance value between the line one and line two maximum distances, so I'm just choosing the line one. Why? Because why? Tell me. Because the line one maximum distance will be value is higher than the line two maximum distance. Okay. So I can write over here for betterment the maximum distance. Although it is already written, line two does not have the maximum space than the line one. So maximum space value of line one is higher than line 2. So the student asked me questions that we can have the infinite lines of n number of lines. Of course, it is possible. So this would be the iterative process by which we have to choose the best line, and selecting the best line is known as the hyperplane. So suppose I'm choosing the best line by which I can split the my data, and this best line is known as the hyperplane. Now this term is clear.
Yes, sir.
This okay. Let me move to the definitive part. So hyperplane. Do not think about the other terms. So the following terms are more important to understand the SVM. So what is the term hyperplane? Just look at only the hyperplane definition. As you can see in the our diagrams, as you already see, it is a decision plane or space which is divided between the set of the object or that which are the data points by the different classes. And what are the two classes we have? One is a male class and one is a female class. Now it is clear right now. Now let us move to the our important point. So now what is the now it is clear to all right now why I'm choosing the line one and what is the maximum space. These two terms are clear.
Yes, sir.
Yes.
Clear.
Yes, sir.
Okay.
Clear.
Okay. Super.
Sir, there is
Ah,
might be possibility.
yes. Tell me.
There is might be possibility that the group of girls hide. One or two maybe they are in the line of boys again after just reshuffling.
Resupplying may be applicable when we are dealing with a large volume of data. So we are getting this kind of problem, and so to troubleshoot such problem, what we have a kernel function. And what is the kernel function? Kernel function is a function that is used to transform our data set into the one dimension into the another dimension. Just like if I'm using the uh, one dimension, then I was unable to find the proper classification. So what I will do, I will transform. That is the point. A kernel function used to transform your one dimension data set into the another dimension data set. It means one dimension to 2D we are transforming, then we have to use a kernel function. And what are the kernel function? The best kernel function, which is the RVF, which stands for the radial basis function. So that is the basic or the important kernel function in the support vector machine. We can sort out the problem, and that is also possible. And same thing we can find in the two dimension. As you can see over here, and a few couple of the minutes ago, you have seen while starting the class, some data points are not easily plotted because the data points are given, but we are not easy to classify because they are shuffling or they are just coming onto the each and every group. So what I will do and what we can do, we will use a kernel function. The kernel function will use to transform your two-dimension data set to three-dimension data set. So by the three-dimension nature, we can easily understand the thing. So that is the beauty of the kernel function we have in the support vector machine, and that is the point. Of course we can do. So that is also possibility. If we are try to solve any problem in this world, so we have a lots of the possibility. So we have to find what is the possibility we can choose to sort out the problem, and that is the kernel function in the support vector machine we have. So we are discussing all the problems. So if you remember the my words, I have already written statement. uh, the problem that can be sorted out by the kernel function also. The kernel function definition is to transform one dimension data set into the another dimension. That is also possible, and it is also so. We have a solutions. Now to clear right now.
Yes.
Okay. See, kernel function is not a part of the syllabus, but I will share my slide so you can easily understand. If your time permits, then I can explain by the practical as well. Support vector machine supported by the kernel function. We have a good example by which I can explain. Okay, no issue. So first, we have our objective to just look at the syllabus part. Then other time permits, so definitely I will explain all the thing, the information beyond the syllabus. Uh, so after understanding this point or after determining the maximum space and getting the thing, why I'm choosing the line one, because of the it is determining the or just having the higher value. I'm talking about the higher value. Okay, so we can say this is the our best selected line, and this line is known as the hyperplane. Now, let us come to the this point. So well, yes, this is our best fit. So now this is the point. Now let us discuss the right now here some important terms. Hyperplane we have already discussed. Now here we have a three important terms. What are the two terms? Support vectors and hyperplane and margin. Hyperplane we have seen. Now it's time to discuss about the support vector as a name given into the topic support vector machine. So support vector machine is the name of the machine learning algorithm. But what is the meaning of the support vector? Why it is given the support vector? So as an interview person can ask you the question. Okay, support vector machine, you're telling me it is a machine learning algorithm, but why it is known as a support vector? So what is a support vector? That is the point. So support vector is nothing which is just simply defining that the data points, the data closest to the hyperplane is called the support vector, and the separating line will be defined with the help of the these data points. Okay, so I have an image by which I can easily explain what a support vector. Just look at this image and you can discuss. Just look at this image. Yeah, and I can zoom it this image so for your betterment. Yes. Are you able to see this image where two data points from the different groups are depicted by the circle and which are just pointing by the points, and these points are known as the data points. Is it clear to right now?
Yes, sir.
Okay, now good. After understanding this point, so let me remove this curiosity by the our graph as well as we have drawn. So what we are doing today, we are just looking at the our graph and we are same looking at the same thing by the pictorial representation as well. So the our idea will be more visualized and clear. So now let me go to the our example once again. So this is a good way, just this way. So can you tell me what are the support vectors in this example? What are the support vectors? No, blue color. I must take the black color over here. Yeah. Tell me what are support vectors over here? Can we say out of these data points, which data points are closest to our hyperplane? If we are choosing this line as a hyperplane, so if I'm choosing the line one as a best line, okay, I can write over here. It's the best line. So this line is also known as our hyperplane. Okay. So I'm writing here hyperplane. Now come to the point. So can you tell me right now which data point will be? First, we can say this would be the support vector because this is the only data point which is close to our hyperplane. Tell me yes or no. Can we say from the
Yes, sir.
female? From the female, this is data point which is closest to our hyperplane. So this would be support vector. Same thing, we are having the multiple support vectors. We are classifying our information. So this is the point. We are not having the one support vector. We can have the multiple support vectors. So we have to speak support vectors. So can you tell me right now? We can choose this one or we can choose this one. So it's your choice which is the data point you want to do. So we are assuming over here this data point is closest. So this would be the our data point. This would be the support vector. So I'm writing here the support vectors. And this is the definition. Support vectors means the data points which are closest to the hyperplane. That is the reason we have a support vector. And from this point, we have our topic support vector machine. Support vector machine. So why I'm giving the support vector machine? Because this is a term. So now we have seen the two terms: support vectors and hyperplane. These two terms are clear to all right now. By the graphically, it is clear to all right now. And this is the discussing. We are discussing about the functionality of the support vector machine algorithm. Okay, so the picture, the idea should be clear to all your mind as well. Now it is clear to all right now. So for anyone who need to ask any questions, please you can ask. We have a graph. We have the pictures. Just tell me right now. Yes, tell me anyone who have any. Okay, so now let us look at the other term, margin. So margin is telling to us that define the gap or the space between the two lines on the closest data point. As a student asked me, so we can have the multiple lines. Of course, we can have the multiple lines, and we need to find the best line based on the maximum space. But this space could be good or bad. That is the point. So what is mean by the good or bad? So let us understand. I was speaking about the good margin. So good margin means we have a maximum space. When we have a less space or smaller space, so we can say this is the bad margin. So margin means we are discussing about the space between or the gap between the two lines. So the parallel line which was depicted by us into the sky blue color as you have seen into our drawn graph. So we have to pick the large margin based information. So in the hyperplane is the just line which is chosen by us. From the maximum space, from we are identifying the large gap. You can easily understand by the graph only. Yeah. So here I am choosing the line one based on the maximum distance, and this maximum distance will keep the large margin. They will keep the large margin between the two parallel lines. Why I'm not choosing the line 2 as the best line and it is not a hyperplane to our problem? Reason is clear. It contains the low margin or it contains the small margin. So why I'm not choosing the line 2? Because it has the low margin. So these are the three terms are clear to all right now. Low margin, hyperplane and support vectors by the our graph as well. It is clear to all right now. Yes, tell me.
Yes, sir.
Everything, yeah, everything I have drawn in front of you. From our pictures, from our solid problem as well. So here, from this parameter, you can tell me right now what would be the class of the our new input data as we have taken. Yes, tell me. Yeah, this is the new input data. So what would be its class? Just tell me right now. Now answer you already know. So this is the point. Yes, tell me. This point is clear right now. So we can easily determine the our new input data will be female or male. Yes, tell me.
By the line one, it would be male.
No, you can't say by the line one it would be male. After solving the problem, line two you are not able to choose because it does not contain the maximum space. So we will discard the line two, and like the line two, we will also discard all those lines which are having the lesser margin. We will keep the higher margin baseline, and so we have chosen over is the line one. So line by the line one, definitely we can say that our data will be the Bell category one. So this is the simplest answer. Yes. Now it is clear. Just anyone who need to ask any point, so please you can tell me.
No, sir. Clear, sir.
See all these things are already described by the our pictorial representation. So I'm just I have all the images. So I would like to show our answer. Okay. The rest of the thing you can read out from the PPT. See, based on the hyperplane, it is clearly mentioned. It is clearly written, and which is the line one. Okay. So I can just write over here for you, and this one is our line one. So we can see the new data points belong to the male gender. So that is the symbol we are using. So now you can see. And D1 plus and D1 2 just margin between the hyperplane to the our support vector. Okay. The distance between the hyperplane and the support vector. So what is the positive? D plus is saying to us. What is the D positive? D positive is studying the distance between the positive, or we can say the our selected uh, data point that was a new data point belong to the male category. So from the support vector which belong to the male category, the distance between the that object in that data point to the line. So we have the D positive. And why I'm writing D negative? D negative means because new data point was not belong to the female, so that will be identified by the D negative. So the distance between the hyperplane and the closest data point of the female group, so that is identified by the D positive, D negative. So why I'm positive? Because new data was belong to the male. So this is the reason we are putting the positive symbol only. And if you combine these two terms, D positive plus minus, so we will get the maximum space. So let me write over here. D positive means this is the between distance between uh, male support vector. I can write over here male support vector and hyperplane. Now this is a hyperplane, and D negative belong to the distance between the female support vector and hyperplane. So this is the reason negative is coming due to our new input data was not belong to the female. So this is only reason. Okay. So can you tell me right now if I will add these two terms D positive plus D negative, so what I can get? If I add these two distances, so then what I can get it? Can anyone tell me right now? The answer you know. Yes, tell me. Can anyone tell me right now?
Can you repeat the question, sir?
So I'm asking the distance. We are adding the two distances. One distance belongs to D plus and D minus. So what is the distance? Which is this distance equivalent to the our 1 point? Can you tell me right now?
Sir,
Yes, tell me. It's a very simple answer. This distance will be the our maximum distance. This will be if we are adding the these two distances. We have already calculated. So what we are doing? We have a d plus. D plus the distance between the male support vector and the hyperplane, and the d minus is the distance between the female support vector and that. So this is it. We are drawing the dotted line, that is the upper sky blue line, which will be closest to the, or which will be passed to close to the our uh, the support vector. So this is the distance. So this will be equivalent to the maximum distance. This is the reason I didn't say that my previous slide we have this point. Now just look at my previous slide. This one. D plus is the shortest distance of the closest the positive point, and shortest distance of the closest negative point. So we have maximum we can write like this way. So this is equivalent. This is the reason I didn't show this slide. This is the point. So now I will explain over here. So margin, distance vector, distance, space, and all the parameters are clear to all right now. It is clear to all right now. All these
Yes,
steps.
sir.
So this is just what this was the support vector machine. So that was so clear. It is clear to everyone right now. So now we can say the line one is the optimal line. So this would be the hyperplane. So we have already seen. So new data will be the our mail.
Sir, excuse me, sir.
Yes, tell me.
Sir, what if the new data is on the
You're talking about the what is the problem if you need data on the.
line? If data is on the line.
See, that is the good question you're asking me right now. What we will do? You just for you just removing this question. I'm just showing the image which you can easily understand. When we draw the line, we will not draw the line on the line. We will take the or we will draw the line by using this parameter. Just to look at. See, we will draw the line by the we will draw the line not on the line from we will take some space from the we have to choose a different point from which we will start the draw the line. If you're drawing the line, there will be no sense because on the line if you're drawing, so you will not easily to identify. So how you can classify the problem? For your problem, what I can explain. Uh, just let me go to this point. uh, just what I'm doing, I'm just going to my example, then you can easily understand. You are asking the good question, so let me remove your this curiosity and just I'm just trying randomly over here. Okay, so this is a one group, this is another group. You're talking about this one. Okay, so this was a new data. Okay. So you are telling me, sir, can we draw the line on this one? So if you are draw the line on this data point, so how you can classify? Can you tell me right now? Do you have any answer for this one?
No,
Is
sir.
it possible? No. So what you will do, you will choose the appropriate point from which you can easily. So see, we will discard those lines which are on the line. So we can draw the line like this way. Okay, we can draw the line like this way. Or we can also have the some line. We can also draw the line like this. Yeah, definitely, we can also have. We can also draw the other line like this way. So that is the only point. So we will not use the line which are uh, drawing on the data points, new data points. So that will be discarded. That will be not applicable. We will choose only those lines which are not on the data point, and from the our drawn line, we will choose the or we will select the best line, and that is a parameter maximum space or maximum distance. We will choose the appropriate line, and that line is not in the hyperplane. So that is the only reason. Now, because we will, if we're choosing the line which are on the data point, so the classification will not be applicable, and our algorithm will not work properly. So we will get the garbage bill. So we will not justify the algorithm. That is the point. So SVM does not use this kind of approach. Now, clear right now?
Clear, sir.
See, it is just like simple example. You're standing on a bridge and you are just need to cross the country by the bridge. So you will stuck. So if I ask you the question, from which country you are studying, you don't have an answer. Can you tell me?
No, sir.
Because you are on the bridge. So if you're coming on this point on the left side or right side, so you can easily say, sir, now I'm in this country, I'm in this country. That was my point. Now clear, this point is clear?
Yes, sir.
Okay, good. So now after understanding all these points, the functionality of the data support vector machine by the our simple example. So everything is already mentioned over here, but I've also taken my own graph to explain my idea. So you can read out this PPT in detailed manner as well, once again for the revision purpose. So if I ask the question in the examination, just explain the functionality of the support vector machine. You just take an example. You can take a ref example and draw the graph and explain all the parts what you're doing on that graph and how you can say the new input data belong to the X class or Y class. So you have to explain something by the some paragraph or something. So I can easily understand. At least you did the hard work to explain your idea in the examination. So take your time to explain all the points. So this is the only point. So this is okay. In this slide, it is saying to us so far we have decided the line one is the best line, so we have chosen. But does the guarantee every time the line which is selected by us that is the optimal or not? So to understand this problem, we have this Lagrangian support vector machine. So LSVM we have, and that is a basic algorithm which will be the by default we can use in the support vector machine in the machine learning as well. So what we have LSVM. So what the approach is, what the approach we have seen by the our support vector machine and by the functionality we can see so far. This is known as the support vector machine, and it is, we have the preceded by the one word that is the Lagrangian support vector machine. So at the time of the interview, anyone asks you the question by default, what is the approaches we will use to understand support vector machine? So you have simple answer. Sir, we have seen, we know the basic or the default category of the support vector machine. We have a LSPM, that is a Lagrangian support vector machine, and it is a fast technique to training the our data by the support vector machine model. So this would be definitely iterative process to find the support to select the best line or hyperplane. So because we can have the n number of the line, so which line I must choose. So I will apply an iterative process to find the best line to judge or to based on the mechanisms. So this could be the reason. And so this is a point you have to keep in mind. So this is when I'm putting the slide over here to tell you which kind of the approaches we have taken inside the support vector machine, that is known as the Lagrangian support vector machine. So this is the point you have to keep in mind. Okay, so now everything is clear. So we can process to the type of the support vector machine. So just tell me if you need to ask any question. So we can move on the type of the machine, type of the support vector machine. See, I have a simple example and nothing else, so by which you can easily understand. And the student asks the many questions, so their curiosity will be or their answer you can easily find by this type of the support vector machine. Rather than theoretically, I can speak the everything by the simplest. Yes, can you tell me right now? Now, can we move to the type of the machine, support vector machine?
Yes, sir. Continue, sir.
Okay, thank you. So we have a two type of the support vector machine. One is a linear support vector machine, other one is non-linear support vector machine. Here, please keep in mind the linear non-linear means we are talking about the data points. It means I can write over here. Just let me mark into the circle form. So what is the meaning of the non-linear non-linear means? It is defining by the data points. Okay. Data points. We are talking about the data points or nature of the data points that would be depicted. Nature of the data points that will be depicted on the graph. So let me explain the thing by the help of the simple way. First, let me speak the definition of the linear support vector machine. Linear support vector machine just used for the data that are linearly separable, as a name given over here. And for example, you can say a data set that can be categorized into two categories. Okay, as we have seen the male and female, yes or no, true, false, we can use. So we can say the utilizing the two categories. by utilizing a single straight line. Such data points are termed as a linearly separable data and a classifier, as we can say, described in the linear support vector machine. So our example was the support vector machine that is used by the linear by default. Let me take this example. You can see there are multiple lines you have. Are you able to see this image?
Yes, sir.
So good. So here we have a line one. This is line one. Here we have a line two. I'm writing L1, L2, and this is a L3, and this is a L4. So we can have this one. So from this point, we have a question: which line I must choose? So I must choose a line that is dependent on the maximum space, and this would be the optimal hyperplane, optimal line. So you can easily see in this one. So what you are doing? This is the line which is selected by us. So we can say this is the best line. This is also known as a hyperplane based on the maximum space or maximum distance, maximum margin, or it is also known as a large margin. Or it is also known as the large margin. From this parameter, what you are doing? That is again another question. So you can easily say that our data are separated by a line. This is the point. Now you can easily say we have the two class of the data. One belong to the class one, another belong to the class 2. So our data are classified into the two form. We're talking about the binary classification by the line. So linearly separable is possible. So this is an example of the linear separable. Now it is clear to all right now. The basic things are clear. Yes, tell me. The basic things are
Yes,
clear.
sir. Yes, sir.
Good. So if I talk about the one more image, I will tell you. Then you need to tell me what is the point and how can sort out such problem. Before jumping to that part, let me explain the other type of the support vector machine, that is a linear, non-linear support vector machine. So in the non-linear support vector machine, the straight line division is not possible. Non-linear support vector machine used for data that are not that are non-linearly separable. And example, we can take the straight line cannot be used at any cost. It is not possible. So for doing this one, what I do, I will share the image. Just look at this image and tell me, can we separate the data by linearly in this example? Yes, tell me. It is also possible or not? Okay. According to you, just look at this. Can you use this line L1? Data is linearly separable. Data is separable because blue triangle are coming also into the red square part. Okay. So if you want to use this one, you can use this line 2. But you can easily say some triangle also mixing into the. So that is the problem. So here we can say the linear separable, we can say linear separable is not possible. So this is the point I'm speaking to all the people. So linear separable is not possible. Then what we have to do? We have to use a thing which is known as a kernel function. So kernel function is required. Kernel function. So it is required. It is required to separate the data, separate the data, separate data. Okay. So if it is possible, then what is the purpose of the using the kernel function? To transform one dimension data into another dimension. I'm writing very simple way, dimension, another dimension data. It means you have a one dimension, so you will transform into the two dimension. And if you're unable to separate data in the 2D, so you will transform to 2D to the 3D. That is the problem. So this is the problem we are having into the non-linear SVM. That is a non-linear support vector machine. Okay, so this was our points we have discussed. So close to analysis, if you remember the my words I told you, uh, uh, kernel function we can use. So kernel function, we have a different type of kernel function. So I'm just remembering some names so I can speak RVF, which is a most famous, that is a radial basis function. And other than the RVF, we have a sigmoid kernel function. And what is a sigmoid? I have already explained inside this concept in the logic relation. Okay, linear, we have non-linear, we have polynomial, we have, so we have the linear, non-linear, polynomial, RBF, sigma. These are the various flavor of the our kernel function. So when we have any kind of the problem, when we need to separate the data by linear way, so we can use a linear kernel function. Non-linear we can use, so we can also use polynomial. We have to use, yes, of course, because when the we are using the polynomial representing our data, so polynomial way, so separable is not easily possible. So that is the reason we have to use the polynomial kernel function we will use to separate our data. But by default, what is the kernel function name we have to use in the Python programming? That is the RVF we have. We have also in the Python as well as we have the mathematically as well. So what the RVF does in the simple word I can speak, it just pick the some data points, and a result of the our this kernel function will be known into the distance between the point and some fixed point. So from this pattern, the our RVF or the our kernel function will. So this is just idea about the support vector machine and its type we have seen today. So you have any problem to understand all these points? So you can ask me as we have discussed. Yes, tell me right.